How do we simplify if we have a rational expression where the numerator and denominator are both monomials? So if we have, for example, this rational expression, 2a squared b cubed c over 10ab to the fourth c squared, and we'd like to simplify this. Well, what we want to do is be able to cancel out common factors. Looking at the coefficients, here I see a 2, and I see that 2 is a factor of 10. Right, 10 is 2 times 5. And in my numerator, I just have 2. I see a's in both the numerator and denominator. Here I see an a squared. That's a times a. I see b's in both the numerator and denominator. Here I see a b cubed. Here I see a b to the fourth. B to the fourth is b cubed times b. And then here I see a c. Here I see a c squared. C squared is c times c. Why did I split these up in these specific ways? Because now I can recognize the common factors. What's left? Well, in my numerator I have only an a left. In my denominator I have a 5, a b, and a c left. And now I look again and say, do my numerator and denominator still have any common factors? No, they do not. Is this the shortest way to write this out? No, not really. Let's see another way to write out simplifying something like this. Let's suppose we have the rational expression 14x squared yz to the fifth over 20x y to the fourth z. Well, I notice that my coefficients have a common factor of 2. If I cancel out the 2, what's left of the 14 is 7. What's left of the 20 is 10. And now those no longer have any common factors. I notice that both have some power of x as a factor. I can cancel one x in the denominator with one of the x's in the numerator. That cancels out the x in the denominator and leaves me one fewer x in the numerator. I can cancel one y in the numerator with one of the y's in the denominator. That gets rid of my one y in the numerator and leaves me 3 y's in the denominator. I can cancel my z. That'll leave me one less z in the numerator. What rational expression does that leave me with? Let's see, I have a 7 left, an x to the first, which I'll just write as x, a z to the fourth in the numerator, and in the denominator 10y cubed. And again, I see I have no common factors any longer. What did I do here? First, for the coefficients, I canceled any common factor. Then, for the variables, each variable appears in the answer in the place, numerator or denominator, where we saw the higher power, and with an exponent that is the difference of the two original exponents. So here originally I saw a z in the numerator and in the denominator, but I saw a higher power of z in the numerator. I subtracted 5 minus the first power of z in the denominator. There was a z to the fourth remaining in the numerator. I'm going to give you a couple of these to try. Simplify each of these ratios of monomials. Pause the video and try this now. Alright, so for the first one, In the coefficients, I see that 5 and 25 have 5 as a common factor. Z to the fourth is the larger power of z. I'll cancel out both factors of z in the denominator with 2 of the factors of z in the numerator, leaving me with 4 minus 2 is 2 factors of z in the numerator. I see u squared and u to the fifth, more factors of u in the denominator. How many more? 5 minus 2 is 3 more. X to the first versus x to the seventh, more factors of x in the denominator. How many more? 7 minus 1 is 6. So what am I left with? In the numerator, only z squared. In the denominator, 5u cubed x to the sixth. Second rational expression. The coefficients there's nothing I can do with. 10 and 7 have no common factors. Z's more in the denominator. How many more? 5 minus 1 is 4 more. V's more in the denominator. How many more? 5 minus 2 is 3 more. And so I'll have only 10 left in the numerator. 7 z to the fourth v cubed in the denominator. This last one, in the coefficients, 11 is a common factor. I'm left with 1 and 2. Z's more in the denominator. How many more? 4 minus 1 is 3 more. U's more in the denominator. How many more? 7 minus 1 is 6 more. X's more in the denominator. How many more? 7 minus 2 is 5 more. Y's only show up in the denominator, so no canceling at all happens with those. All right. What's left of my numerator? I've canceled everything. When I've gotten rid of everything by division, all that's left is the number 1. In the denominator, I'll have the coefficient 2, z cubed, u to the sixth, x to the fifth, y squared.